Hello everyone, and welcome to the presentation for the paper titled End Users and Industry 4.0 Systems Cyber Resilience from Cross-Site Scripting Attacks. The authors of this paper are Cvitic, Dragan, Perakovic, Sinisa, Husnjak, and Dominik Sever. On today's presentation agenda, we have firstly introduction, then related research that inspired this paper. In the third section, I'll say a few words about cross-site scripting attacks through analysis and classification of cross-site scripting attacks. Then I'll present you a simulation that was conducted for the purpose of this paper in section Cross-site scripting attack simulation using AB framework. After that, I'll talk about synthesis of results and the proposal of protection guidelines through methods that were tested in this research. And in the end, of course, a conclusion. As we are all aware, there is an increasing number of companies that provide their services over the internet. Of course, that is a good thing, but problem occurs when there is increasing number of cyber attacks that come alongside. So any user connected to the internet can be the target of a cyber attack. Since Industry 4.0 is characterized by high usage of information and communication technologies and concepts such as Internet of Things, cyber threats can compromise industrial management system in Industry 4.0 environments. Therefore, companies and organizations can suffer big damage by cyber attacks. In this paper, we focused on cross-site scripting attacks as one of the most common types of cyber attacks. Regarding related search, we have three here. The first one titled Preventing Persistent Cross-Site Scripting Attacked by Applying Pattern Filtering Approach. So authors suggest defense method by applying filtering based on defined samples. It is suggested to apply filtering on event handlers, uniform resource identifiers, or shortly URI, unsafe keywords, special characters, and so on. The second one, titled XSS, server-side detection of cross-site scripting attacks, suggests detecting reflected cross-site scripting can be done by matching input and output data and checking for similarity. In other words, if an attacker injects a malicious script an HTTP request, that script should be fully contained in HTTP response. Therefore, detecting cross-site scripting can be done by matching input and output data and checking for similarity. For stored cross-site scripting, authors suggest analyzer with list of known scripts. So if some new unknown script appears, it is most likely an cross-site scripting. The third one is mitigating cross-site scripting attacks using a reverse proxy. So it is a server-side solution that works as a reverse proxy. All data that is returned back to the user must pass through a reverse proxy with the implemented detector. So if a detector detects an unknown script sent to the user, the response is blocked. Regarding cross-site scripting, it is a type of cyber attack that is performed when an attacker implements a malicious code or script into a seemingly harmless website or web application. Most used programming language is JavaScript because it is a language used for web development and it is being executed in the web browser. So malicious script is also executed in the attacked user's web browser. The cross-site scripting is classified in three classes. The first one, called stored or non-persistent cross-site scripting, where the attacker's malicious script is stored in the web page database. So any website visitor can be a victim of an attack. Most vulnerable types of websites are forums, blogs, social networks, and so on. Basically, the types of sites that have input fields like comments and so on, where attacker can implement his script. The second type is reflected or non-persistent cross-site scripting. In this type, malicious script is not stored on the web server or database, and therefore it is mostly used for a targeted attacks because attacker can craft a link with his malicious code and send it directly to a targeted victim. And the third type is document object model based cross-site scripting. It changes DOM-based environment in the victim's browser. So response does not contain an attacker's payload. Therefore, it can be hard to detect with server-side detectors because the payload manifests itself only on the side of the user's browser. Regarding trends in cross-site scripting attacks, here we can see two charts with most common cyber attacks in year 2017 and 2018, and the data is provided by organization PT Security. As it can be seen, the cross-site scripting is always in top 3 of the most common types of attacks. There can be some variations between the top 3, but cross-site scripting is always at the very peak. For newer data, we have this chart for the year 2020 from the company EdgeScan, and it shows the most common critical vulnerabilities in 2020. As it can be seen, cross-site scripting is again at the very top of the chart. From this and the previous slide, it can be concluded how much of a threat cross-site scripting is. Now we can continue to the simulation section, and here can be seen a simple diagram that depicts the simulation setup. The attacker is a computer with Kali Linux operating system and the BIF framework installed on it. For the purpose of the simulation, the simple HTML page was created and a Apache server started, so the page can be accessible on the local network. In the HTML page, the hook JavaScript script was implemented. The script was provided from the BIF framework, and therefore when opening the page on the other computer or the attacked side, the browser was connected to the BIF framework. Here we can see the BIF interface and connected browser in the top left corner. We can read its IP address. Immediately after connecting, some relevant information can be seen, like browser the attacked user is using. In this case, it says Chrome. The browser's engine, in this case, it is Blink, so yeah, that is good. The CPU architecture, even the graphics card that is used on the attacked PC. In the simulation, we simulated 5 different attacks that are available in the BIF framework. The first one, pretty theft, in the form of a Facebook login pop-up. Then the Google phishing, detect the social networks, get page HTML, and redirecting the browser to the malicious payload. The last one is the most complicated one, and it is the most malicious one. Here we can see the result of 2 of the attacks. So after user enters its credentials in the Facebook pop-up window, his email and password is shown in the BIF interface. So the attacker can log in into his Facebook, for example. And the below one picture is a result of fetching open sessions. As you can see, it returns if user is or is not logged in some of the social networks or services. This can be used in combination with other attacks like previous Facebook pop-up window or something like that. Google phishing has a similar result as pretty theft. It opens a Gmail login page and sends an input to the BIF interface. And after executing get page HTML, attacker can see a HTML code of the web page. The last attack was done in combination with Metasploit framework. To be more precise, its model MSF Venom was used to create a malicious payload. So the payload needs to be created and sent to the attacked computer to gain remote access to the computer. In the below picture, you can see the interface for redirecting the browser. Here the payload is named setup.exe because it could be name misleading in the real life situation. The attacked user downloads the malicious payload and executes it, and through a listener active on the attacker side, attacker can have a complete remote access to victim's computer. He can navigate through directories, download files from his computer, send files to his computer, change files, for example, change some text documents that could be imported for him, execute commands through command line, and so on. All in all, a lot of very dangerous actions. Here on the picture you can see the result of ls command that lists the files and folders in the documents on the remote computer. For the synthesis of the results, here in this table you see again those 5 attacks, and Pretty Theft and Google Phishing both pass user credentials to the attacker. Therefore, attacker can have access to the login information. Also, there is possible compromise of other services as well if user uses the same credentials for other services or networks, and that is a very common thing today. With attack social networks, information is visible in the interface if the user is logged into one of the offered networks. That information can be used for further attacks. Result of getPage.html was the HTML code of the open page. That information can be used, in example, for planning of further implementations of malicious code in the website or something like that. And the last one, redirecting the browser to the malicious payload, compromised the victim's computer. We were able to fetch files, send files, execute commands, and so on. In this table we have 4 defense methods that were tested. The first one is JavaScript blocking. It is the most simple one. It is available in most of the web browsers. It blocks execution of JavaScript when opening the page, but the problem is that it blocks all of the JavaScript, also the good ones and the ones important for the work of the website. So some pages can be not usable anymore. The second one, uMatrix, proved to be a very good solution. It is implemented as a plugin in web browser and is pretty easy to use. The downside is that it could possibly give a incorrect verdict to the risk, thus blocking something that shouldn't be blocked. But that happens very rarely. In this simulation, the malicious script from Beef was blocked, and Beef cookie was seen in the uMatrix log. The third one, Xpeer, is a tool that needs to be installed on Linux operating system. It detects vulnerabilities in the provided websites. It could be complicated to use for everyday user, but could be a good tool for web developers to test their websites. The last one is burpsuit. It can be installed on Linux, Windows, Mac, and it is quite a powerful tool. The browser needs to be set up to send data through burpsuit, and that way it detects a malicious script. In this simulation, the script was also blocked, and therefore the browser was not connected, and further attacks could not be conducted. And for conclusion, we can say that cross-site scripting attacks are one of the most common types of cyber attacks, and there are a large number of different end consequences that are possible for the attacked user. Therefore, the user must take certain measures to ensure the protection of his computer and his data. Between the tested methods, uMatrix stands out with a good ratio of simplicity and functionality for the end user and for everyday use. And the Xpeer stands out as a good solution for developers to detect vulnerabilities to cross-site scripting attacks. And thank you for your attention.